Okay, on a problem like this, we're finding particular solutions to separable differential equations. So this is your differential equation. Now I know this is a differential equation because it is an equation that has a derivative in it. We also have this initial condition, okay? Knowing that we have this function or this equation y, when we plug in -1 for x, we get 1 for y. So using this information and our differential equation, we are trying to figure out what is the x value when y is equal to 2 of that function. So we need to take the antiderivative of this, okay? So let me write this down over here. I'm going to rewrite this 3y squared plus 2, that whole thing times dy dx, our derivative, is equal to 1. Now, what I want to do, the reason why we call them separable differential equations is because we can separate this out, meaning that I can take this dx that's over here and move it to the other side. So here's what we get. We're going to get 3y squared plus 2 dy is equal to 1 dx. Now, I think of this as multiplying dx on both sides. Okay, multiply this side by dx and this side by dx. Technically, you can't do that for various reasons, but I'm not going to get into that. But we often just say that we move it over. So once we are here, we can now integrate both sides. And if I integrate this side, then we're going to get 3y cubed over 3 plus 2y. And then I'm going to take the antiderivative of my right side, which is just going to give me x and then plus c. Now, the weird thing is that we don't need the plus c on the left side, just need it on the right side. Kind of weird, kind of confusing on that, but that's the idea. So from here, what we could do is divide out our 3's, okay? So then you have y cubed plus 2y is equal to x plus c, okay? Now, we call this our general solution, okay? And so, what we want to do is use this now to figure out our particular solution, okay? And then figure out and then do some algebra. All right, so given our general solution, we use our initial condition here that when x is equal to -1 and y is equal to +1, we can solve for c. Okay, so now our next objective is to solve for c. And so from here, x is equal to -1. So I'm going to do -1 plus c, and then I'm going to plug in 1 for y, so 1 cubed plus 2 times 1. All right, and all I'm doing is just plugging these values into my general solution to get a particular solution. So from here, 1 cubed is 1, plus 2 times 1 is 2, is equal to -1 plus c. 1 plus 2 is 3, and that's equal to -1 plus c. Therefore, 4 is equal to c. All right, and this will help us write our particular solution, which is y cubed plus 2y is equal to x plus 4. Okay, now we answer the question, what is x when y is equal to 2? So from here, we plug in 2 for y. And so we're going to get 2 cubed plus 2 times 2 is equal to x plus 4. So now 2 cubed is 8 plus 2 times 2 is 4 is equal to x plus 4. From here, your 4's can cancel out. If you subtract 4 on both sides, and you get that x is equal to 8. And that is how we do things like that with differential equations.